Okay, so we're going to look at another example on derivatives of hyperbolic functions. So let's say we are given a function as y is equals to, it's a rational function, 3x squared over uh, hyperbolic cotangent of over 4x. Okay, so I want to try to find the derivative of that. So what we're able to see there is that we're able to use the quotient rule as well as we're also able to use the product rule. So it's just a choice that we have to make to say, okay, now which one do we use? And in my case, I would love to use the quotient rule. So what I'll do is that we are going to say our u is equals to the numerator, which is 3x squared. Then our denominator is going to be our v. Okay, it's going to be our v, which is equals to uh, hyperbolic cotangent of 4 of x. Okay, so I need to find what the u prime is, or the du dx. That will give us I want to have our 6x there. Then our v prime. Okay, our v prime, which is just basically the derivative of the hyperbolic cotangent of 4x. And we can write this in three forms. We can either say the hyperbolic cotangent of 4x is equals to uh, is equals to is equals to minus 4 hyperbolic cosecant uh, cosecant squared of 4x, or we can also use 1 minus hyperbolic cotangent squared of 4x, but of course we have a 4 outside here. Then we can also use uh, minus 4 multiplied by 1 over um, hyperbolic sine. Okay, hyperbolic sine squared of over 4x. Okay, but it's up to you. You can use this one, you can use that one, or you can use the first one. I prefer to use the first one, but either ways, whether you use the second one, the third one, or the first one, so you're going to get one and the same thing. So to remind ourselves, um, the question true, what we do is that we are going to say it's a v u prime or v du dx minus u v prime, or is sometimes it's written as u dv dx divided by v squared there. Okay, so we're going to say our v multiplied by our u prime. This is our v multiplied by the what? The u prime there. So that's 6x multiplied by hyperbolic cotangent of 4x. That is 6x hyperbolic cotangent uh, hyperbolic cotangent of 4x there. Right, then we are going to say minus u multiplied by v prime. So keep in mind we have a negative there, so meaning with this negative is going to be positive. So we are saying our 3x squared multiplied by 4 hyperbolic cosecant squared of 4x. What you're going to get is 12x squared. You're going to get 12x squared hyperbolic uh, cosecant squared of 4x over v squared. And in this case we have said our v. Okay, we have said our v is equals to hyperbolic cotangent of 4x, meaning we are going to get hyperbolic cotangent squared of over 4x, like that, which is simply the final answer. This is a derivative of what we have right here, and that's how simply you go about that question. It's just a matter of knowing how to differentiate hyperbolic functions, as well as being able to know to say, okay, I'm using the product rule, or am I using the quotient rule. It's basically up to you. It's up to you to choose which one we want to use, but you arrive at the same conclusion. And even if sometimes it might not appear the same depending on what kind of derivative you have used for v prime or the dv dx, if you try to simplify it, if you just try to replace in terms of identities, you're going to come up with the same conclusion. So that's how you go about that question. Thank you very much for watching.